Go.
Hello.
Hello, Miss Terry, are you alright?
Yes.
Okay, so today we talk about a math problem, math puzzle, which is called Hanoi. How do you pronounce this? Hanoi Tower? Hanoi. Is it Hanoi? Hanoi Tower. Yeah, Hanoi Tower. So we have only three. Yeah, we have first of all we have three rods. So the rods. Okay, 3 rods. So this is A, this is B, this is C. So we have A, we call it disk. Okay, we have disk, N disk. If there's only one disk, they play, initially the disk, N disks are placed on the first lot. Okay, so if there's only N equals 1, how many moves does it take to move this A to C, given this condition? Yeah, you only these sticks, yeah, is usually the smaller place on the larger one, so you'll be like that disk. Yeah, you'll be smaller on the last one, place on the bigger one. Okay, so this the smaller can only be placed on the bigger one, and you're only allowed to move one at a time. Okay, you can't take more. You can move one at a time. Okay, and then we want to move all the disks from the left rod to the rightmost, which is C, from A to C. So if there's only one, then we can just do just move it. Yeah. All right. Okay, so if we use the T to represent the number of the minimum moves. Okay, the minimum T1 equals 1 is easier. If N is 1, T1 equals 1. Okay, more interesting. If there are two disks, how are we moving this? Can you tell me? B has to be placed on A. A can't be placed on B. Okay, because B is smaller than A. Okay. So how can we move this AB to here, from A to C?
B put on B.
Yeah.
A put on C. B put on C.
Okay, so how many moves?
I forgot.
Okay, let's try again. 1, 2, 3. Okay, 3 moves. Okay, now it's more interesting. C. Okay, there are three disks. Okay, come on, play again.
C put on B. B. Oh no. B put on C. C put on B.
Okay, let's do it. Okay, C put on B. Okay, can C put on B? Yes. Yes.
I mean C on C, yeah, and then A.
You want to restart? You can restart. I think there's something, the opposite order, because eventually you want to put A to C, and now this taken the place. Yeah? So should we restart?
Oh yeah.
Yeah, don't worry, let's do it again. C put on
C.
Yeah. 1,
B put on B.
2,
C put on B.
3,
A put on C.
yeah.
C put on B.
Huh? C already on B.
C on A. B on C and C on C.
So 5 plus 2, 7, yeah? Okay, great job. So if there are N, it gets more complicated, right? If there are 4, 5, 6, it gets more complicated. But the essentials are the same. So what are we trying? What have we done here? Is we want to move the top, there are N, if there are N, yeah? If there are N here. We want to move the N minus 1, yeah? N minus 1, including the last one, yeah? We want to move these two here, right? Yeah? And then we move to here, right? Yeah?
Why do we need to put it on C?
Because this is the target from A to C. We are moving everything from A.
Yeah.
Yeah. So this process is similar. We just need to this n minus. We want to move the n minus 1, but we don't know how to move yet. But we can move this n minus 1 to the middle, right? Yeah?
Yeah.
And then we move this because it's only 1 now, right? So I only move it to here. And what's next? I want to move this too back to here, right? Yeah? So now only 3 steps. 3 steps. So look, Tn equals, first of all, I want to move this to here, right? That's Tn minus 1, right? Yeah? Plus here, plus 1, then n minus 1 again, right? Okay, so what does it equal? Tn equals 2 times Tn minus 1 plus 1. Okay, so can you tell me what's T4? Based on this, Tn equals 2 times Tn minus 1, previous one plus 1. So what's T4? T3 is 7, T4 is 2 times of T3 plus 1. 2 times 7 plus 1.
15.
What's T5?
T1.
Well done. Yeah, you got the meaning, yeah? So yeah, like that. So what's this equal? Okay, what's this equal? We can prove it. T1 equals 1, Tn equals 2 times Tn minus 1 plus 1. Okay, so remember we talked about the mathematical induction before, yeah? What does it mean? It's a methodology to prove that a formula stands. How do we prove it? We have a formula, we prove that the basic case, T1, it stands. And then we're assuming Tk, and then we want to prove that Tk minus 1 also, or plus 1 also exists. Okay, let's do this, and then you understand, okay? So actually this Tn is equals 2 times to the power of n minus 1, yeah? Remember, the T1 equals 1, T2 equals 3, T3 equals 7, yeah? T4 equals 15, yeah? 2 to the power of 4, 16 minus 1, 15. 2 to the power of 3, 8 minus 1, 7. 2 to the power of 2, 4 minus 1, 3. 2 to the power of 1, 2 minus 1, 1, right? Yeah, this is the equation. But how can we prove this is right? T1, we just prove it. When n is 1, T1 equals 1, that's fine. If let's say Tk, let's say Tx, yeah, Tx works. Tx equals 2 to the power of x minus 1, right? And then what's Tx plus 1? Tx plus 1 equals what? Tx plus 1 equals what? 2 times this, yeah? 2 times Tx. 2 times what? 2 Tx plus 1 equals 2 times Tx. 2 times Tx plus 1, right? So this is 2 times this bit. 2x minus 1 plus 1, right? Yeah? So equals to what? 2 times 2x is 2 times x plus 1 minus 2 plus 1. What's minus 2 plus 1? Look, if we substitute this tx with this, then we can get this 2 times 2x plus 1 minus 2 plus 1 is what? Is what? Is minus 2 plus 1. Oh no, it's not. Oh, 2tx is 2, yeah. 2x is 2 minus 1, right? 2x plus 1. Look, tx plus 1 equals 2x plus 1 minus 1. Okay, so it also works, yeah? Because look, alright, x plus 1, yeah? Substitute. So it also, it proves that Tn equals 2n minus 1 because Tn plus 1 equals 2 times n, 2 to the power n plus 1 minus 1, right? It's the same form. Okay. Yeah. So we can write this simulation. Okay, we can write this simulation. Define move. Okay, let's move. How many disks? N disks. We want to move from source to destination. Yeah, and then we have another road. Temp. Let's call it temp. Okay. If n equals 1, What does it mean? If we only have 1, we just move, yeah? We just move. If n equals 1, let's just move it. Print, okay, move disk, okay, I'm just writing this 1 from source to destination, yeah? Because there's only 1, right? And then we return. Okay, there's only 1.
I thought to spell disk is D-I-S-C.
Oh, that's maybe American's English. I don't know. D-I-S-K, D-I-S-C. Yeah, similar. Okay. Return. Okay. Then if not, look, we move what? We move. Look at it. If there are more than 1, so what do we do? What do we do? Remember what do we do? What do we do? If there are more than 1, we move the top n minus 1, right? Top n minus 1 from source to the temp, yeah, to the middle one, right? Yeah, to the middle one, and we use the destination as the intermediate temp, yeah. And then we need to do what? Print. We want to move what? Move disk n, this n from what? From source and then to, this is another move, to destination, to destination. And then now, what's next? We need to move this n minus 1, yeah? Move n minus 1 from what? From what? From what? From what? Come on. From to source to destination, to use the destination, and we need to move from, because now it's in a destination, right? So we need to move from destination, yeah, to what?
To source.
To what? Come on. To what? Move. Have a think about it. Think about it from what? Temp to so actually it's because now it's in destination. It's in a temp. Yeah. This is temp. Temp. We want to move to destination. Yeah. Destination. Right. We'll move here. Temp. Because look, I already previously I moved n minus 1 from source to temp. The middle one is the temp one. And I want to move from the temp one to the destination, right? And then using the source as the intermediate one, as the temp, right? So let's be source here. Got it? And now that's the algorithm to solve n, arbitrary n. You can put 100 here, and the computer will print the step for you. Got it? Yeah? So you see, so if you n equals 4, it's easy. Your recursion. Look, this is recursion, yeah, because we are recursion in solving n minus 1, right? Because we are focusing on one step at a time. We want to move the n disk. All we want to focus is move the top n minus 1, yeah. We want to move the top n minus 1 from source to the middle one, right? And then I want to move this, the second step, move this to the destination. And I want to move this to here. Right? Yeah? That's the recursion. Okay. So let's say if one test, T5 equals how many steps? Remember the equation I just proved before that. 2 to the power of n minus 1, yeah? So 2 to the power of 5 equals what?
Wait.
Huh?
50. 31.
31, yes, 31. Okay, got it. Yeah? Got it?
Yeah.
Any questions so far? Any questions?
No.
Okay, good job. Okay, that's it for today. Good job. Okay, do something at the end if you want. Okay, that's it.